Good afternoon, everyone. Give me just a minute to finish setting up. All right. This week, we are going to start on arrays. And here's when we can really start putting together all of the things we've been learning so far about repetition, a selection, etc. So far, we have had the ability to work with variables to store values, but we've kind of been limited to a one-off basis, if you would. If I need to store a value, I make one variable. So one-to-one, I have to kind of anticipate what I'm going to need and create as much storage as I need ahead of time, as much named storage as I'm going to need ahead of time. Of course, you have the use cases such as, when we were trying to calculate Fibonacci, we had 3 variables that conveniently we could just reuse over and over again. But what do you do when you need more than that? And you can't really anticipate how much storage you're going to need. I don't know how much I'm going to need, and I don't have the ability to come up with random names for all of those things that I'm going to need. Well, then we have things like arrays that we can take advantage of. A basic definition of an array is an indexable structure that is able to store 0 or more of the same data type, 0 or more things of the same data type. I'm a little reluctant to use the word objects here because depending on what language you use that in, that can mean something different. I was going to try to give an example in JGrasp using Java, but I'm rusty on Java, so I gave up on that, and we're just going to try to draw the idea at least here. Let's get rid of that. So indexable structure, what does that even mean? Oh, didn't get out any of my drawing tools. We have some examples in here as well, but I like to draw. I think it makes sense here. So typically, we'll look at an example in a moment. Again, variable 1, variable 2, variable 3, right? And each of these may store a value. So I have 3 variables. Let's just do numbers 1, 2, and 3. And of course, we have our semicolons here versus this array. And we can think about this array as 3 variables. This is, in this example, we actually have 3 variables, but they don't have names. So instead of that being variable 1 and variable 2 and variable 3, that's index or position 0 or position 1 and position 2. Right, so now I have a really easy way to create something that can store many variables, and I have a really convenient way to name them. It's just a number. So if I have 10 things, then the variable I want is one of those numbers in the list 0 through 9. If I have 20 things, the variable that I want is some number between 0 and 19. Right. So I have a very easy way to interact with this collection of items, if you would. So here is a similar example in the slide. Right. So we have here these 3 variables, and the other term for variables that are only able to store one value is scalar. So the variables we've been working with the entire semester so far, they've all been scalar variables. There've been examples of scalar variables. They can only store one value. So X can only store, for example, 3. Now I can store a different value in it, but it can only hold one at a time, right? So that's the limit. How many can it store at one time? Versus an array. So here is a variable, and the name of the array, arrays have names. So the name of the array is becomes the, let's say, variable name, if you would. But this variable is capable of storing multiple items, multiple variables, if you would. So now I have a variable that can store multiple variables. And the way I access each of those is just by their number. Right. So if I want the first variable, I say, hey, give me my array variable 0. Give me my array variable 1. Give me my array variable 2, etc. That's how we interact with it. And specifically, we would use these square brackets here. Right. So here again, imagine this was our array name. This is the name for our array variable. An array is a non-scalar variable. And we have these brackets, and this is how we indicate which variable in the list we want. This is called an index. This number, the technical term for that is an index. So I want the variable at index 0. I want the variable at index 1, the variable at index 2. So we can think about these numbers as if they were variable names. So as a matter of fact, this entire thing becomes the name for that first variable, right? So we can think about it that way. Let's go. Let's talk a little abstract and a little more concrete about what that actually is. Because it's nice to understand this, especially for us. I think most of us in here are electrical engineers. We're going to need to work with physical components, and this understanding is kind of important for most of you in here. So let's pretend this is physical memory. Right, so this is a stick of RAM in our computer. You know, how does this relate to that? Well, that array name in C and in other languages, this is actually an address. And we'll talk about address variables later, but this is actually an address. Imagine this memory is located at address, you know, in hex 32. We'll make it up. It's not a real address for us because that's typically reserved for something else. But let's pretend that what it is. Then this actually stores that value. That's actually what the value of that variable is. It's the starting address of our sequence of memory that stores our collection of variables. So an array is a contiguous piece of memory that can store multiple variables. And the array name is the starting address of that collection. So here, let's say this is an array that, you know, 1, 2, 3, 4, 5, 6 variables. Contiguous in memory, that's the first address. Now, what that index is actually referring to some offset from that beginning address. So if I say I want variable number 1, I'm really saying I want 32 plus 0. Oh, well, 32 plus 0 is just 32. And if I say I want variable number 2, or this one, I'm really saying I want 32 plus 1. And 32 plus 1 is right here, right? And 32 plus 2 is right here, and plus 3. And I think we all get the idea, right? So that index is kind of our variable name. In reality, what it is, it's an offset from the beginning address of that block of physical memory. That's what that is. So, and this picture is somewhat simplified, but that's mostly accurate. Right? I think it's a mostly accurate way to think about it for now, for what we've known. So arrays can have different dimensions. Right? You can have one-dimensional arrays. They're typically called vectors. Not always. These names aren't set in stone, so sometimes they use these names interchangeably, but often if you hear the word vector, we're talking about a one-dimensional array. If you hear the word matrix, you're talking about a two-dimensional array. Think about like an Excel spreadsheet, right? It has tables and columns, rows and columns. And arrays can be more than that. Arrays can be 3, 4, 5. They can be multidimensional. Sometimes they call them matrices. Sometimes they just call them multidimensional. So how do we use arrays? So we kind of understand what they are. Hopefully, we kind of understand what they are. How do we use one? Well, let's take a look at one-dimensional arrays. Let's start with that. That's the simplest use case, where you have an array that's just one row. How do we work with those? Well, in C, we have to start by declaring a data type. So even though an array, bless you, even though an array is a variable, that variable has to have a data type, just like other variables. Recall that we are a special kind of variable that's capable of storing multiple variables. And that data type tells us what kind of variables we can store. So data type, variable name. So far, this doesn't look any different than any other variable we made. But here's the different part. We have the brackets and some number. That number tells us how big the array is. So in this example here, right, that number would be 6. 1, 2, 3, 4, 5, 6, because this array can store 6 variables. So that's what this number represents. This is an example of declaring an array. So this is the equivalent to saying int x. So if we were to compare this to just making a scalar variable, if we were to compare this to making a scalar variable, right, int x, that's a scalar. I'm declaring that int array, we'll just say 10. Right, I'm declaring to the computer that I want to make an array variable that can store 10 integers. That's what I'm saying. I haven't put any values there yet. Now, if we wanted to declare and initialize this, we could do it like that, right? Int x, that's statement number 1, and then assign it a value immediately. So initialize, just remember we said that the word initialize just means to give it an initial value at creation time. So I create it and give it a value at the same time. That's what that means. You can do that with arrays as well. Of course, that can only happen once. So if you wanted to initialize an array, you would do it kind of like this here. You would have the curly brackets followed by a comma separated list of values. So if you did that, you actually don't even have to provide this number. C will infer that number from the list that you give it. So if we go here, for example, and we did something like int array brackets, I'm going to leave it empty, equals, and we could do, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 items in that list, and close it, and C will read this list. It will infer the array size from that list, and it'll create the array and put those things in each of those elements for you. So we go, let's go back to our picture. So in this example, if we were just to continue this, let's just use 1 through 6. C would create this piece of memory for us, and then it would actually populate it with those values. Now, this is the only time when you create the array, that is the only time you have the ability to set multiple values with one instruction. So typically when you're interacting with an array, you can only work with one element at a time. So element is another word for, let's say, variable, one of these things. So that's this item here, that's an element. This second index here, that's an element, that's an element, that's an element. So when you hear me use that word, I'll use it a lot. Hey, how do I get the third element in the list, the fourth element in the list? I'm referring to one individual array item when I use the word element. So that's the only time you can ever interact with multiple elements in the array with one instruction. After that, once the array has been created, you're limited to working with one element at a time. So you can see right here, imagine we had this array and it had a couple of things in it. my array 0. So here's my array variable. Here's the index of the element that I want. And then in this example, I want to set it to a particular value. So I'm going to set it to 1. And that would just put 1 in that column. My array 1 equals 2. Of course, if I wanted to retrieve the value, I just wouldn't have the assignment statement here. So aside from this bracket and that index, we use it just like a regular variable, right? So it shouldn't be that, it's not that complex understanding how to use it. So if I wanted to, for example, change the value of X, I could do that. If I wanted to change the value of this first element, right, array 0 equals 5. You do it the same way. That becomes, conceptually, we can think about it like our variable name. The same thing, if I wanted to make another variable and set it to whatever X was, we could do it like that. For the array, we could do the same thing, right? So aside from the fact that we're using this, right, it's our array variable plus the offset or the index. We use it just like a regular variable, right? So you use it the same way you use a regular variable, except for this array syntax here. We just have to understand how this works and how to do that. But that's pretty straightforward, right? Just give it an offset, which element you want, use the brackets, and it will access that element. Now, let's go back to this picture here. When you are creating the array, the number that you put in here, if you're putting a number in here, represents how many items you want. Once you have created the array, it never means that again. The number that you put in here, once you have created the array, represents the index of the element you want. Now notice how we're starting at 0. We're not actually starting at 1. So this is something that throws a lot of people off too, because you make an array with 3 things in it, but the first position, the element at position 1, is not number 1, it's number 0, right? And it has to do with this interaction here. So recall we okay, well, wow. Well, because I lost it. I don't really know what happened there. Ah, there we go. So it has to do with the fact that the way it actually works, right? It's an address plus an offset, but just keep that in mind. There is going to be a difference. So if you have an array of size 3, index 3 is not the position of the last item in the array. That's actually outside of the bounds of the array. The array doesn't have a position 3, right? So let's take a look at 2-dimensional arrays. 2-dimensional arrays are going to be similar. The only difference, we're going to have 2 brackets instead of 1, of course, but you'll have 1 bracket for each dimension, and it's always the same dimension. The first pair of brackets is always going to be the index of the row you want. So if you think about a 2-dimensional array like a table, this first pair of brackets always represents the row count, and the second pair of brackets always represents the column count. And just like 1-dimensional arrays, when you create it, here we're creating it, that first number, that's how many rows I want, that's how many columns I want. But after that, from this point forward, when you're interacting with it, that's the index of the item you want. So you want to go to row 1, which is the second row, because we start at row 0. And here I want to go to column 2, which is the third column, because we start at 0. So row 1, 1, 2, 3, and you can see right here what this statement would do. That would go to that intersection of row 1, column 2, and then we would work with that variable or that element right there. We would either set the value or retrieve the value. You can initialize 2-dimensional arrays as well. So remember, initialize just means set all of the values at once. You can only do that when you create the array. So if you look at this example here, what do we have? You're going to have your curly brackets, just like we had for 1-dimensional arrays. And then for each row, you have another pair of curly brackets. It's just a comma separated list of row descriptions, basically. This is row 1, that's row 2. If you had more rows, you would have more curly brackets, right? And you just have commas in between each of your rows. All right, let me see how many slides are here. 29. Let's skip this for now. We'll come back to this if we have time. But I would encourage you to try some of these self-study exercises on your own just to get a little bit of practice with arrays. We're going to use them a lot in here, and it's a pretty well, I guess everything we're covering, all the concepts covered in that we are covering in this class are pretty fundamental concepts to C or programming in general, the ideas anyway. So if you do, again, I would encourage you to try to work through this self-study. Your goal here is just to create these two arrays. That's it. Create these two arrays with these values. This is a two-dimensional array. That's a one-dimensional array. And then try to print several of the values from each of the array and try to change several of the values. Then, of course, reprint them to make sure that you actually did it, just to get some practice making and working with arrays. So loops. It turns out that loops are probably one of the most common ways for interacting with arrays. Loops are used very often with arrays, and conveniently, if you think about how a loop works, right, we have a very easy way to use a variable and that has a changing value that changes in a known way, right? So I can create a variable, in this example, I, and I can I have it so this variable changes from, let's say, 0 to 10, right? Or 0 to 9, which conveniently happen to be all the indices of my array. Or maybe if there were certain indices that I wanted to modify and not others, we could very easily take this loop. And then for our index, we would just use our loop variable, right? So what do we have here? Let's say x equals 4. That's going to be the size of our array. Now we have our the bound, upper and lower bound for our for loop. I is going to start at 0. That's the first element in the array. As long as it's less than 4, right? The last element should be 3, 4 minus 1. And what are we going to do? Well, here is the element I want to work with, and here's what I want to do. We're just going to set it equal to 1 through 4, right? Because I starts at 0, so I is going to be 0 through 3, and we'll put 0 through 4. It's a very 1 through 4. It's a very easy way to initialize the array or do something with every single one of the array elements. If we back up, I thought I had an example here in summing stuff up. I think that was in our repetition lecture. Remember when we first introduced repetition, one of the first slides, we talked about summing up values, right? So imagine if you had an array that had all the numbers stored inside that you wanted to sum up, right? That's the example I was giving. You could very easily have a loop that iterates through each of the array elements and just adds that to your sum variable as you go through. And that's very easy to write, right? So we have this instruction that would look the same on every iteration because I is automatically changing for us. Nested loops. Nested loops, I think we talked about, no, we haven't yet. Yes, we did. We talked about while loops already. That was the last section. We talked about loops, for loops, and while loops. With two-dimensional arrays, a very common way to work with them is to use nested for loops, right? Where you have one loop representing your row or column, and the other loop representing the other whichever one you didn't represent the first time. Typically, it's going to be row and then column. But if you wanted to reverse it, you know, if you wanted to go through the array differently, you could represent different things. But you can see right here, here's our, we'll call it the outer loop. And we have our loop counter variable. And eventually, this variable will represent all of our row numbers, right? We only have 2 rows, 0 and 1. And this inner loop, we're going to use to represent all of our column indices, right? We have 0 through 2 as our column indices, 0, 1, 2. And then here, we're going to do something with the array. So if we were just to take a look and we had to guess, what would this print the very first time it executed that print statement? What would this print the very first time we executed that print statement? 10, very good, that's right. Because I is 0 will drop into this loop. We understand how for loops work already. J is 0, so we're actually printing my array position 0, 0. And that's going to be this element here. Now, the next time we execute this instruction, what are we going to print? I got a 5 and an 8. 5s, raise your hand. 8s, raise your hand. Well, it's about a 50-50 split. So how do nested loops work in C? That's so generally when we're executing a loop, before you can go back and before you go to the next iteration of the loop, what do we have to do? We have to complete all of the instructions that are part of the loop body, right? So what happens to be one of the instructions inside this loop, another for loop. So before we can go back to the next iteration of this loop that uses I, we have to finish all of the iterations of this loop. So J is going to be 0, 1, and 2 before we go back to I and make I 1. So we'll actually print 5. J is going to be 1, and we're going to print 0, 1. And then we're going to print 0, 2, right? So J is going to be 0, 1, and 2. We've completed that inner loop now. There are no other instructions due. We're going to go back to the top, increment I. I is going to be 1. And then we're going to print what? 1, 0, 1, 1, and 1, 2. So self-study number 2. Again, I would encourage you, this one is going to be a little more difficult. I would encourage you to play around with it if you have time. What I would like you to do is create these 2 matrices. And let's do this in 2 parts. Initially, just try to do matrix addition. If you don't know what matrix addition is, you take 2 matrices up and you add up pairs of elements. So for example, this matrix 3, 0, 0 is going to be 1, 0 plus 2, 0. So 4 plus 1, that should be 5. And this position right here should be 7 plus 4. That's what this should, that'd be 11. This position here would be 19. This would be 16 plus 13. So that's matrix addition. You take the same position at every array, the first 2, add them together and save them into the third one. The other thing you could play around with is trying to get something like this to work. So we've talked about loops. We've used for loops before. How could you populate this array using that function right there? Could we do it? It's just 3n plus 1, right? So the first position is going to be 3 times 1. 3 times 1 plus 1. That's going to be 4. 3 times 2 plus 1. 3 times 3 plus 1. 3 times 4 plus 1, etc. Right? And then, of course, we have a different formula that we would use to populate the next array. And finally, this is probably the most complex, but not too bad. It builds into another piece. You can't, this has to do with matrix arithmetic. You can't actually divide on matrices. You can add matrices together, you can subtract, but there's no such thing as matrix division. What you can do is something called inversion. You can invert matrices, and that's kind of the equivalent to division, but you can't always do that. So one way to check on whether or not an array is invertible is to perform a Laplace expansion. And what you do is you take, let's say, this array here, and you multiply these 2 things together. Save the answer. You multiply these 2 things together and you subtract one from the other. If it's anything except for the number 0, it's possible to invert it. You can invert it. If it's a number 0, you can't. It's an array that you can't invert. So that's a pretty straightforward problem to solve. And one of these is and one of these isn't. So the exercise here is to take these 2 arrays, perform that, multiply, subtract one from the other, and then just print out whether or not it's invertible, right? So if the determinant is 0, if that result is 0, you say, hey, you can't invert these. If it's not, then you could say, hey, this is the matrix is invertible. If you want to know a little bit more about how that works, you can click here. 2 by 2 is a fairly straightforward one to implement. They do go more than that, but it gets more complex. as you start getting into larger matrices. So stick with 2 by 2. That's probably about as much as we're going to be able to do for now until we learn more. But it's an interesting exercise. I think if you do these 3 self-study exercises, you should have a pretty decent grasp on arrays, how they work, how to interact with them. So we've kind of done this part already, right? But we'll come back to this, how arrays look in memory. So this here is my picture of a physical memory. Right? So let's pretend this is the RAM in our computer. And this is kind of how things map from our computer program, our source code, what we're typing in our C file, to physical memory in the computer. Imagine we had this array that could store 6 integers, right? Again, in C, an array is always going to be sequential cells in memory. So if you have an array of size 10, it's going to be 10 contiguous cells, one right after the other. That's the way they have to be in memory. If there's not enough space, they'll put it somewhere else where there's enough space for 10 things. So we'll have here element 0, element 1, element 2, right, and so forth. And then maybe right after that, you create another variable. So this might be the very next available memory slot on your RAM that your computer is allowed to use. So you can see here, if this were your RAM, these first 6 cells would be your array, and then the very next cell is going to be X. And if you had other things in here, we'd have, this is just the other variables that exist in your computer program. 2-dimensional arrays, how does that work? Well, they still have to be linear in memory either. Also, they still have to be linear in memory. There are a couple of options for how we can do this. C is a row major language. Some languages are column major. That just means that they store 1 row at a time in memory. So I have a 2-dimensional array. How do I put it in memory contiguously? Well, I store 1 row at a time. So row 1 goes in first, and then row 2 goes in next. And if there were more rows, the next row would go in, the next row would go in, and the next row would go in. So if we were to view this in memory, here's an array 2 by 3, it still has 6 positions, but we would have row 1, here's our array, these 6, the first 6 cells. And the first 3 cells here, that's going to be row 0, and the next 3 cells are going to be row 1. And then again, here's our additional variable, other variables that are part of our computer program. So here are a couple of things you have to keep in mind when you're dealing with arrays in C. Number 1, C does not track any of this for you. There are languages that when you make an array, they remember how big they know how big it is. So if you make an array of size 10, it remembers that. And then if you ever tried to give it a position that's not actually part of those 10 cells, they'll warn you or they won't let you do it. C won't do that. C will just say, okay, that's what you want to do, go for it. And that could potentially be really dangerous, right? You could accidentally erase values of other variables. If we consider the fact that memory is laid out like this, and let's take this one here. Let's say I go to position 6 that doesn't exist, right? I might actually erase what's here because C will just let you do it. That's fine. That's a memory address. It's this address plus something. C will just go to the address and do whatever you tell it to do, unless it's a region of memory you're not allowed to touch. So you have to be really careful with that in C. C doesn't track that to you, for you. If you're passing an array as a parameter, we're going to look at using arrays with functions, because you can pass arrays as parameters to functions if you want to. If you're doing that, you can't just give it the array. There are, well, sometimes you can, but as a general rule, depending on the size of the array or the dimensions of the array, you typically also have to give it a size variable. You have to tell it how big the array is. And we'll talk about why in just a moment when we go to that. C doesn't check, again, if I give it a number that's not part of the array, if my array is size 6, and I say, go to array 10, index 10, it'll just do it. It won't ask, it won't check. So you're responsible for that. And the other important thing is that once you create the array, you can't ever change the size. If I make an array that can store 6 things, it will never be any bigger than that, and it will never be any smaller than that. If I need more space, I have to make a bigger array and copy everything into my new array. Let's take a look at arrays as function parameters. And this is a little bit confusing, I suppose, because passing it to the function is a little bit different than how we would typically use the array. So first of all, here's an array, you know, size 10, and here I'm using it with a function. So I'm passing it to a function. Notice that I don't put the brackets in here. Okay, so if you're passing an array to a function, it only wants the array name. We don't care about the brackets, just give me the name of the array. And also notice, so here is a variable that I'm using to store the size of my array, that the first parameter I'm giving it is the size of my array. Right? And what C will do, remember we've talked a lot about how functions work and the fact that you can't see into the, let's say, memory of another function, right? So here, if I'm in my main, oh, that's how you do that, huh? Oh, well, that doesn't work. All right, so here's my main function, and in here I make an array, right? So array 10, let's just say that. And I have another function here, we'll call function 1, where I accept the array. So the number 10, you pass in the array here. What has to happen, there are a couple ways to do it. Here, right, here's my array, these 10 cells, but then right below this line, that is the memory for function 1. And what I have to do, I have to remap this into that. So you have to tell me how big it is, and I actually have to redo that mapping in here because I have to recreate those values. So depending on how you use this, that's one thing that needs to happen. So because I don't have access to your memory, I don't know how big it was. C doesn't track that anyway. When you're passing it to a function, one of the things you need to do, you also need to give it that size so it can redo that mapping for you. Okay, so it can allocate its own range of cells. It needs to know how much space it needs to allocate for that that array. If you are defining the function, right? So someone remind me really quick of what the difference is between using a function and defining a function. What's the difference? I'm sorry? So which one is that? So what's the difference when using and defining a function? When you're defining it, so when you're defining a function, you're describing how that function behaves. So you're not actually doing anything. So this is not, when I write this, nothing's happening. I'm just saying, hey, if you use this function, here's what it's going to do. In this example here, when you're calling the function, you're actually doing those things, right? So the definition is what's going to happen when you call it. And this is you actually calling it and saying, hey, go ahead and execute those instructions. So when you're defining a function, when you're saying how the function is going to behave, this is how you would define your parameters, right? So remember your parameters when you're defining a function is just a comma separated list of variable declarations. So you need a variable to store your size, and you need a variable for the array that's going to be passed in. And we see that right here when we're using it. I'm going to give you a value for the size, and I'm going to give you an array that will be saved into that variable here. And then we just use it like a regular array. So here we have a loop for I equals 0, I is less than whatever that was, and we can just go through our array and do stuff. In this case, we're just going to print it. If you have sometimes, let's say you have only a partially filled array. Like you don't have to fill the entire array. You might have this big bucket of storage if you would, and you're just kind of filling things in as you go, but some of it's empty. But maybe I need to process that list, or I need to process some part of that list, right? What could we do? Well, we could do something like this. We still have our size, we still have the array, but now we're going to pass this third value that represents how many elements are actually in the array. And again, let's go back to the languages that track some of this for you. Languages that store the array count for you, they often store things like this too. So you don't have to remember that. You just type in the array and say, hey, how big are you? How many things are in you? And then you can just get that information from the array variable itself. And see, you can't do that. The array variable is just a variable, and you have to remember all that stuff. So the last two self-studies, self-exercises, if you would, just take those previous two, right? The Laplace expansions and the matrix addition, and try to put those in functions. Try to write a function that'll do that. Try to write a function that'll do that. So you can work with this. Now you can work with the arrays as parameters, and you're doing that stuff inside the body of that function. So common issues, we've kind of covered this already. Here's some common errors that people will run into. Indexing errors. So here my size is 10, and I'm attempting to access position 10. And of course, this is wrong. I don't have a position 10. What's the index of the last element for this array? 9. It's always going to be the size minus 1. Very good. And again, recall that the array is always implemented as a consecutive group of memory cells. So here's our some program variables. Here's our array 0 through 9. And then, right after that, just other variables. All right, questions. Let's take this example here. And let's take this first set of statements. The question is, can you do it? Is this possible in C? So I'm creating an array of size 5, and then immediately below it, I'm going to attempt to set all of the values for all the positions. And you're shaking your head no. Why not?
Because you already declared it and everything. So if you put that up with it when you did it initially, and you realized it, then yes, you could. But now you sit there and go in the time.
Very good. You can only do this when you declare the array. So once you pass that line, if you want to interact with the array, you have to do it one element at a time. You can only do it as a group. You can only declare it. I mean, you can only initialize it when you declare it. If you did it on this line, it would be fine. Next question. Here's what we have. Imagine we put some values in it, and then we attempted to change the size like this. True or false? Can we do it? What would that even do anyway? If, let's say, my intention was to change the size, and we just said that we couldn't do it, would this do anything at all? Go ahead.
Would that call up whatever is, in this case, however many positions beyond the last memories?
That would attempt to go to memory position, whatever the starting address is, plus 10. Very good. That's what this would try to do. So once you create the array, you can't resize it. Doing this would actually attempt to go to position, starting address plus 10. That's what it would try to do. And of course, we don't have 10 positions, right? We only have 5. So it would be 4 would be the last element. Finally, what about this? Is this okay? That's a weird one. Here, it would actually give you an error because the dimensions don't match, but sometimes it won't. So it's weird. If you make it too big, you can actually partially fill it, and that's okay. If you leave this blank, it'll auto declare the size for you. This is wrong, though, if you declare the size to be too small and you try to give it too many things. So that's a weird one, but maybe it's kind of intuitive. Let's see. Let's go to, I think it's here. I have my stuff. Let's go to this and just take a look at that really quickly. We still have a couple minutes. Include, and we don't need any special libraries to work with arrays. It's one of the base parts of the language. Let's just do int main And here, if we try to do something like this, int x3 equals array, right? 1, 2, 3, 4. We can see it should complain about this, right? Excess array elements. So too many things. That's the maximum size. I tried to give you 4 things, but this is okay. It will let you do that. And it's not wrong. This will create an array of size 6, and it'll fill the first 4 items. The last 2 will just be blank. Just won't put anything there. And that's okay if that's what you want to do. You don't have to fill the entire array. And then, of course, leaving it blank is fine as well, right? Or we could, let's do this. And let's just print it and see. For I equals 0, I less than 6, I plus plus, print, and we'll just print xi. Let's compile it and run it. And you can see that the last 2 are just blank. They don't have anything in it. That's fine if you want to do that. What if we did this? Let's try to go to position 10. So obviously we don't have 11, we don't have 10 elements in our list, right? What if we tried to do that? Notice it doesn't complain, and it actually tries to do it. And there's something there. So if we're in memory, the way your computer typically deals with memory in a computer program, we have, here's our memory. Let's say we have, why are you doing that? I don't know why it's drawing arrows. Let's say you have one, some collection of 1s and 0s. Right, this is really what your memory looks like. It looks something like this, a whole bunch of 1s and 0s in it. And when you make your array, so x6, let's say we did that. What C will do, it'll just reserve these 1, 2, 3, 4, 5, 6 spots. But it's not going to blank them out. It's not going to 0 them out. So if there's something here already, that stuff is still there. Now, when I do x0 equals 10, then it will change this to 10. I see we'll do that for you, but these don't change. And that's why when you do something like this, recall we mentioned that C won't try to stop you. If you go out of bounds, it'll just do it. So it went to that starting address plus 0 through 5, which is great. And then it went through plus 6 and plus 7 and plus 8 and plus 9. These happen to have 0s in them. These happen to already be blank. But these 2 actually had some 1s and 0s already. And if you took those 1s and 0s and you interpreted them as a number, that's what number you would get, right? So if that makes sense. All right, so just to quickly recap, we talked about arrays today, what they are. We talked about how they're represented in memory. At a very high level, you can think about an array as a special variable that's capable of storing a collection of variables, and they all have to be the same data type. And that's one of the requirements. We talked about how to create arrays, how to access the different elements in an array. We looked at how they're represented in memory, and we talked about a few of the gotchas that you have to keep in mind when you're dealing with arrays in C. Do you all have any questions for me? Any questions? All right, the next 3 classes are going to be us doing array exercises. All right, some of them are going to be graded in Vocarium graded exercise. Some of them are just going to be regular class exercises that we do together. And if you don't have any questions, have a good evening, everyone, and I'll see you on Wednesday.